Hi, in this question, we need to find the range of y equal to sin x power e plus cos x power e, right? We will see a trick for this question. Let's consider a general graph of y equal to sin nx plus cos per n. And here we are interested only in the region from 0 to pi by 2 or 0 to 90 degrees. This is, let's say, y, and this is, let's say, x. This is, and we are only interested in 0 to pi by 2, or you can say 0 to 90 degrees. So if n is equals to 2, sine square x plus cos square x, that is always equals to. This will be the graph of sine raised to power 2x plus cos raised to identical. Now, if you consider any other power of sin x and cos x, that is, if you consider any other value of n, now we will make two cases: when n is than 2, or when n is less than 2 but it is greater than 0. Why we are considering greater than 0? Because if n is less than 0, then sin x and cos x will have negative power. In fact, 1 upon sine will become cosecant and 1 upon cos will become secant. It should be either termed as secant raised to power nx plus cosecant. So this is entirely different approach, because in that scenario the graph will tend towards infinity, and we will discuss it in the lecture. Here we are only considering about the positive values of n, right? And that too, in this particular example, I am considering only the values pi by 2. We will take further when what happens when x is greater than pi by 2 or less than. Let's consider first if n is greater than, sine square x, n is 2, sine square x plus cos square x, that is always 1. Now if n is greater than 2, sine raised to power nx plus cos raised to, and in 0 to pi by 2, we know sin x always lies between, and same with cos x. So if any value is lying between 0 to 1, whenever we raise its power, the actual value becomes lesser. So sin x is greater than sine square, that will in turn be greater than sine cube x, and so on. That will be greater than sine raised to power nx when sin x is between 0. Right? Same with cos x. Now since power this n, this is greater than 2, we are considering this. So that should be, we are raising the power, so sine raised to should be less than sine square, and cos raised to power nx should be less than cos square x. Hence, sum should be less than 1. So, and also sin x and cos x, the both are symmetrical about pi by 4. The graph should also maintain its symmetry about pi by 4. So when n is greater than 2, now trick for you people. Whenever n is greater, the graph will something like, will be symmetrical 0 to pi by 2 about pi by 4. So if I talk about the range of sine raised to power nx plus cos raised to power nx in 0 to pi by 2, only in 0 to pi by 2, then the minimum value will occur at pi by 4, and the maximum will be either at 0, you can say 1, or at pi by 2, which is the same value, which is. Now what happens when n is less than 1? We can say if n is less than 2 but greater than 0, then sine raised to power nx plus cos raised to power nx, that will be simply greater than 1, because sine raised to power nx will be greater than sine squared x, and cos raised to power nx will be greater than cos squared x, right? In that particular scenario, graph will be something like, again that will be symmetrical about pi by 4. Graph will be symmetrical about the graph will be something like, right? So now let's consider what is the value of this thing, sine raised to power ex plus cos raised to power ex. What should be its range? Clearly we know that is greater than 2, right? Approximately 2 point something. So the graph that will be followed will be yellow color like this. So its minimum value will be at pi by 4 and maximum will be 1 in 0 to pi by 2 only, right? So in 0 to pi by 2, if x belongs to 0 to pi by 2, so minimum will be at pi by 4. So we can find f of pi by 4. That will be simply 1 upon root 2 plus the same thing 1 upon root 2. This is the minimum. So that is nothing but you can say 1 upon 2 raised twice of 2 raised to power e, and that is nothing but 2 power 1 minus e. So this is the minimum value and maximum value will be 1. We can say in 0 to pi by 2, its range is 2 raised to power 1 minus e by 2, 1. This will be the range in 0 to pi by 2. But what happens if x is greater than pi by 2? Then basically we are talking about the second quadrant from pi by 2 to pi, and the third quadrant from pi to 3 pi by 2, and the fourth quadrant from 3 pi by 2 to 2 pi. In any of these second, third, or fourth quadrant, in each of these, either sin x or cos x or both, at least one of them will be negative. And negative raised to power irrational number are not real. So we cannot consider those values when x belongs to either of second, third, or fourth quadrant. Then y will be our imaginary. And since we know that sin x, cos x collectively they both are periodic function with period 2 pi, right? So the values of this particular sin x raised to power e plus cos x raised to power e will repeat after every 2 pi interval. The range will remain this thing, right? So this will be our answer, and I hope you must have learned a simple short trick to find the range of sin raised to power nx plus cos raised to power nx when n is any greater than 0, right? This is what you need to follow. Just find the value at pi by 4, check whether it is the minimum or the maximum. If it is the maximum, then the minimum value will be 1 and maximum will be pi by 4 in 0 to pi by 2. Right now, you need to check whether negative values can be possible or not. For example, let's take one more example of, let's say, cube root of sin x, sin power 1 by 3x plus cos raised to power 1 by 3x. Let's take this example. Clearly, n is less than 2 but greater than 0. So its graph should be like this, right? So in 0 to pi by 2, if I talk about, 1 will be the minimum value. This 1 will be the minimum value and maximum value will be at pi by 4. So let's calculate the value at pi by 4. That will be, these two will be same, 2 upon 1 upon root 2 or 1. Or you can say that will be simply 2 upon power 1 by 6. That will be 2 power 5. This is the maximum value. So, and clearly in the, if you talk about the third quadrant, that is when x belongs to pi to pi by 2. Both of sin x and cos x will be negative, and since cube root of negative is possible, so we have to take all the possible values in first, second, third, and fourth. Clearly in second and fourth quadrant, one of them is positive, so the least value will be in third quadrant when both of them are negative, and that will be simply negative sign of this, which is obtained at pi by 4. And clearly the graph will be continuous. So the practically range of simply this thing, negative of this value minus raised to power 5 by to positive of this. This will be the range when n is 1 by 3. Now let's take one more scenario when, let's say, this is sin power. Let's take cubed. Now clearly the graph will be like, and in the third quadrant the graph will be mirrored image of this. So graph will be the third quadrant, and clearly uh, the graph will be continuous. So maximum value will be clearly 1 and minimum will not be this, because this is only in the interval from 0 to pi by 2, and minimum will obviously be minus. So it's clearly its range will be how much? Minus 1. I hope in today's lecture you must have learned how to find this range without even using. I hope you enjoyed the session.